I wanted to do a couple of other problems as some review before exam 3. So first, an example on the product rule. Here we have h of x equal x cubed times 3 minus 2x squared, and we want to find h prime of x. So first of all, for the product rule, just remember, if you're taking a derivative of a product, it's very easy. It's the derivative of the first function times the second, and then plus the derivative of the second function times the first. That's the way I remember it. You could, of course, switch up the order of multiplication if you like to have alphabetical order, f prime g plus f g prime. Either way works. So here, we can think that x cubed is f, and g is 3 minus 2x squared. So if we write f is x cubed, then that means that f prime is 3x squared. And if we write that g is 3 minus 2x squared, then that means that g prime is negative 4x. So then h prime of x will be, first we're going to have f prime g, so that'll be 3x squared times 3 minus 2x squared, plus g prime, which I'm going to write in parentheses, negative 4x, times f, which is x cubed. And then we should try to think of, can we factor what we've got? So if we take a look at our products and we look for some common factors, we'll see that I can't factor out any constants, but I can factor out some powers of x. So like x squared that's here, I can factor out an x squared from x cubed, since x cubed is the same thing times x squared. So I'm going to factor out an x squared. And what's left then will be the 3 times the 3 minus 2x squared, and then minus the x times the x, which would be x squared. And we can simplify what's inside of the brackets. If I multiply first, we'll see that we get 9 minus 6x squared minus x squared inside of the square brackets. And so what I'm left with in a simplified version would be x squared times the quantity 9 minus 7x squared. And that's it. Okay, here's another example. Now dealing with when we started finding second derivatives. So we need this for the second derivative test. So if we're given an example of the function y equal 3 over x squared, and we want to find the second derivative, we do need to find the first derivative first. So one way that we can help ourselves to do this is, let's write y as 3 times x to the negative 2. Then we can just use the power rule, which means that y prime is going to be 3 times negative 2, which is negative 6, times x to the 1 less power, so negative 2 minus 1 is negative 3. And then the second derivative, just keeping it this way, we'll get negative 6 times negative 3, which is 18, and then x to the negative 4. And then we should write our answers using positive exponents, as we've been doing throughout the class. And so y double prime is 18 divided by x to the 4th. And then an example from the last section that we covered before this exam, applications of max and min. I took this from the offline homework that's in the back of your course packet. A farmer wants to build fences around and across a rectangular field. As shown, the internal fencing costs $12 per foot, and the fencing around the outside costs $3 per foot. What are the dimensions of the field that will have the maximum area and can be fenced for $540? What is the largest possible area of such a field? Use the second derivative test to confirm. So the rectangular field that's shown, you can find this. This is problem number 5 on page 123 of your course packet. That field looks like this. We've got this rectangular shape, but then it has fences on the inside. Like this. And we've got y feet and x feet for our dimensions. So just like we've seen before, since we have a rectangle, it means I've also got y on the left here, and then also this dashed fence that's in the middle. And then I've also got x on this top line, and then also on this horizontal dashed line that's in the middle of the field. So we've got internal fencing, that's the dashed lines, and then we've got fencing around the outside. Those are the green lines, as we see here. Okay, so a couple of things that we're given are how much does it cost for fencing inside and outside this field. We also want to find the largest possible area, and also what are the dimensions that give us the maximum area. So we know that we're going to need something of a formula related to area. So let's just remember that area is just the product of the dimensions. You can think length times width, or one side times another, but in our case it would be x times y. And so we can just say A for area equal x times y. We also do have a restriction in that we want our cost to be $540. So they want to have these fences made for $540. So what we're going to start to do is build a cost function. So let's start with internal fencing costs, $12 per foot. So internal fencing that would be the two dashed lines. So how many feet is that? It's x plus y feet. What's the cost of that internal fencing? Well, it would be $12 times however many feet we have. So the cost would be $12 times the total amount of feet for the internal fencing, which we can also just think of as 12x plus 12y. In the same way, for the outside fencing, how many feet do we have? Well, that would be the sum of the four sides around the field, which would be 2x plus 2y, because I see that I have two sides that are y on the outside and two sides that are x on the outside, feet. And the cost for the outside fencing is $3 per foot. So $3 times the total amount of fencing that I have, 3 times 2x plus 2y, which is 6x plus 6y. So now we can get to what is our total cost. Well, it's the cost for the internal fencing, 12x plus 12y, plus the cost for the outside fencing, 6x plus 6y. So that gives us 18x plus 18y. we call C our total cost, we know that we would like C to be $540. So this means that 540 is equal to 18x plus 18y. And so what we're going to do is take this equation, 540 equal 18x plus 18y, and use that to try to get our area in terms of one variable. So I'm going to solve this for y, meaning I'm just going to get y by itself. So the first thing that I can do is subtract 18x from both sides. And then I can divide everything by 18. So 540 divided by 18 is 30, minus x is equal to y. And then I'm going to plug that into my area equation, which was a equal x times y. I'm just going to put that right in for y, which means that area is x times 30 minus x, or area equal 30x minus x squared. So now to get a largest possible area, we want to think of how did we find max and min before. We used derivatives. So a prime is equal to 30 minus 2x. We want to find the critical points, which in this case would just be when the first derivative is equal to 0. Which means when x is equal to 15, and we test this with the second derivative. And in our case, the second derivative would be -2, and a double prime of 15 is just going to stay as -2, which is less than 0. And as we saw before, that means that we're talking about concave down, which means that we get a max at x equal 15. So when x is equal to 15, that will give us the maximum possible area. So now we can answer the questions, which were, what are the dimensions? Meaning what's x and y? We already know what x is. We can now find out what y is. And then also, what is the largest possible area? So in our case, x is equal to 15. We know that. We can find y by going back to when we had solved our cost equation for y. So y is equal to 30 minus x, which in our case would be 30 minus 15, or y is equal to 15. And then the area is just x times y, which would be 225. And then we just need our units to finish this. X is 15 feet, y is 15 feet, but area is square feet.